So, hi everyone, I'm Jerry Ho from Scroll. So first thing first, today's talk will not be really diving too deep into it. Instead, I want to make you know that from the topmost thing to the bottommost thing, that you get all the keywords, you get their description now, so that after you back home, you'll be understanding, hey, I'm not familiar with this part, so I'm gonna Google it. I'm not familiar with this part, etc., etc. So that I hope that you won't fall asleep because I won't let you fall asleep. So that Scroll's design and architecture is simple for zkevm. So that first thing first, we've heard a lot like state channel. We've heard a lot like state channel, like plasma, and like optimization rollup, layer 2, side chains, zk rollup, zk DVN. You know, those are buzzwords, but sound like buzzwords, but they are not. They, in reality, they represent different security assumptions and represent different layers of security. More on that later. So yeah, the first thing first is trust. Who to trust? Like when in a traditional sense that like take this as an example, VPN versus zero trust. Like in a traditional sense, when you have credentials, you log in, you get into a LAN, and you are free to do anything. And in zero, but that should not be the case in blockchain. I mean, in blockchain, we tend to have like hashes, signatures, and cryptographies and proofs for everything. And yeah, that is a central heart to blockchain. That is like we want to trust code. We don't trust human. And zero trust seems like a blockchain word, but it's not. It is a word in InfoSec, and it is emerging. It's an emerging concept, which means that whatever step you are taking, like when you are reading database, you are writing, you are updating, or you are just querying something, every step of it will be audited inside the specifically designed system. That is, we don't trust you only because who you are, because your credentials. We trust you because that the certain step you've done, it is well within the design intention. So that's it. So the equivalent of that in blockchain is like, remember those words? Sidechains, plasma, in those all solutions, maybe not all, but a little bit in the past. It is like, hey, the design, we can only handle some simple contract interaction, simple transaction or a chain of transactions. But there will be roles like hey, watchers, like aggregators, like, and we have to trust them. There's many assumptions like liveliness assumptions, and etc. And that's not going to work. I mean, it's not going to work even for regular users. So many words, right? So that's why they are in the past. So the most important keyword here is layer 2. When it comes to layer 2, we mean that the security assumption is the underlying layer. That is which, yes, as long as Ethereum L1, the consensus layer is safe, then anything else is safe. So that instead we trust the proof. We don't trust the single point of failure, like the bridges or the contract bridging between those like state channel, like plasma, or between side chains, between L chains to Ethereum main chain. And yeah, here comes the critical idea, abstraction. Some of you may not know about the future roadmap of Ethereum, so let's get through it quickly. So that's it. Thank you for this user. This user on Reddit, this one is pretty straightforward. So that bridges, right? Sidechain or L1s, but it's just bridges only. That means you have to trust here in order to make it work. Yeah, bridges. But in rollups, it's not only bridges. There are proofs from here to here. So rollup, they have to prove to the execution layer that, hey, what I did is correct. You have to trust me. Instead of you have to trust me, you'll be like, hey, here's a mathematical proof that proves me that I've done every step of my state transition function correctly. So proof. Yeah, the S file, trust no one. So we gotta trust no one. Instead, we trust math. We trust nature laws. Yeah. So let me raise an example by Eddie Ben Sassen from Starkware. Our song syntax calculation. You'll soon see the similarities between this one and the proof in the robot. So that, considering you are going to calculate this, computational integrity proof, that means when you are going to do some math, I mean, when there is some kind of math teaching, like for example, you are going to calculate like 3 times by a, you just plus 3 is 6, and 3 plus by 6 is 9, and you plus it by 8 times. And for every step of it, it's called traces, your computational traces, the traces of your program execution, like programming counter in assembly languages. 1, 2, 3, 4, 5. And here, the X is the execution traces to it. So yeah, let me back to a more easy understandable real life example. Considering that it's tax season, we don't want to pay taxes, right? In blockchain, the incentive is important, so it is the same here. We as taxpayers, we have incentive to lie about how much tax we want to pay, right? I think we are crypto people, so we all have those dirty little secrets. But anyway, yeah, considering X is something that your country, your nation, your region knows about your tax data, right? And it's jumping. Anyway, so yeah, X is something you share with your government because you know your tax data and your government knows your tax data. But in order to do state transition function, that is the equivalent here is f of x, that is to calculate, hey, how my tax should be, and you do a lot of maybe slightly hard, difficult calculations, and you get the y. The problem here is that for us, we only have to do our own part of tax calculation, so it will be relatively easy. But for the government, it is not. They have to deal with all of their citizens, and that is hard. So outsourcing, yeah. What if our government wants to outsource the calculation to us? But in the same time, they want us to be honest about the test result, the why. And how can that be done? I mean, we don't want to lie, right? So there is a mathematical tool called computational integrity proof. You can say that it is a subset. Don't blame on me if I get it wrong. It's a subset of zero knowledge proof. That is, there is no zero knowledge in it because the X is visible to everyone. But by calculating that together, you will be generating the proof called pi. Let's code it. You can call that function a trapdoor function, which is like when you are encoding a video like MP4, like etc. S.265, it will be taking a very long time. So it's been using it as a benchmark. But when you are decoding video, I mean, as long as your computer is not like 10 years ago, you'll be fine, right? So for this pi, it will be the same thing. In order to generate this pi along with the y, it will be very slow or relatively slow. But in this case, if our government is going to verify that, hey, in the f of x, I want to confirm that your x is something that I know, and you did not change that in the formula, in the calculation process. And also the y is also correct because I can confirm that, hey, every step of it has been executed beautifully, with integrity, data integrity, and just by looking at pi in a relatively faster time. So that, yeah, everything is solved. That is the outsourcing problem. The government do not want to spend too much computational resources on this, and in the same time, they cannot trust us. So instead of trusting our words, they trust the pi to get and the y that we did on our side. That is the point of computational integrity proof. So can you see the analogy between this one and the Ethereum one? Yeah, this. For layer one we have scalability problems because of some community or some technical debt. Ethereum layer one is not moving like very fast. So instead of doing all the things, all the state transition function in layer one, we instead do that in layer two. But we don't want to be centralized. I mean, look at FTX, look at something else, and being centralized is sometimes we have to sacrifice that in order to change some efficiency, but in the near future or in the ongoing future, we don't want that to be the case. So yeah, by providing proofs, zero knowledge proofs or computational integrity proofs, as Elizabeth Sanson says, that would be a very bright future. So that instead of trusting some centralized entity, no offense, like the side chains we all know of, but instead we can trust on the proofs so that even if let's say Squirrel L2 goes down and people are FUD, they want to withdraw their money, they can withdraw via layer one emergency SD function so that you get to know, hey, Squirrel is in layer 2 because our security assumption is based on L1's consensus layer. That is, you can withdraw, your funds are safe, etc., etc. So trust code, trust math instead of trust human. That is why zk rollup is here. So time to introduce Squirrel. Okay, Squirrel is a scaling solution for Ethereum, correct? We've just learned that. But what do you mean by EVM equivalent? I mean, this word is pretty hard recently between Polygon Hermes, between us, and between some other friend along the road. We are all struggling to make it better. So EVM equivalent. Yeah. So what is EVM equivalent anyway? That is when I'm saying about f of x equals to y. It may sound like easy, but in order to generate the f of x and the whole process, you have to learn a special like math, C, or relatively low-level language, which is called Circon or Hello2. There are invariants. In order to make your smart contract high-level language into something as low-level as assembly language, like this one. I mean, you have to calculate from the leftmost side to the rightmost side, and you have to take care of many, say like registers, variables along the row. And for regular DF developers, it will not be very easy. It will be prone to error. I mean, we don't like being rug pull, right? Consider this fact. If suddenly everyone else who's writing Solidity, writing DF, they are forced to write this in order to achieve scalability, what will be happening? I mean, bugs everywhere. Yeah. So this kind of circuit writing, it is not that ideal, but it is what we have a while ago instead in order to achieve scalability. So what's the solution? Remember abstraction, right? We are going to abstract our system in different level. So just like in TCP/IP, if we abstract the lower level, like when we are writing socket applications, and we don't have to care about how BGP works. We don't have to care about how data link there works. So that's the same case in our thing. I mean, when we are doing state transition functions or writing Solidity, it's being compiled into intermediate representation languages, and it's being fed into EVM and generating some get traces. So this is how it works. This is the X in the example. So by processing the execution traces into that X, we can do some computational integrity proofs, and by feeding them into this circuit, we'll write those circuits and constrain them and into some like Hello2 style proof. And by aggregating them, we can generate a block together with the block proof. So yeah, everything's solved. So just skip this page. The slide will be available later. So this is different level of abstraction. Our friends, we are abstracting our DK EVM to a different level. On the rightmost side, it is the most competitive because it's Ethereum. It's Ethereum PSE18 plus to them. And on the most left side, it is these EVM compatible, but not in a bad way because this is a spectrum. On the leftmost side, it will be more, in a sense, more efficient because it is not something good or bad. No, not at all. It is like they have different engineering trade-offs. You trade your EVM compatibility but instead you get more efficiency. So yeah, people has the right and totally with so many solutions, EVM equivalent solutions available, that we get to have a more robust ecosystem. So yeah, to summarize a little bit, the cost to layer 2 to DK rollup to EVM equivalent. When we are regular developers, we don't care about too much about contract code change. Squirrel does it for us. And second, you don't have to trust us. You just trust Ethereum L1. And third, by doing things in L2, it's faster and cheaper than mainnet. So yeah, this is the link to our Telegram group, especially prepared for Vietnamese people. So welcome to join, and we can talk. You can learn about Squirrel more there. Thanks.